The average number of miles in thousands that a car's tire will function before it needs to be replaced is 70, and the standard deviation is 11. 16 randomly selected tires are tested. Assume a normal distribution. So the distribution of X, which is the original population, we're told is normal, and the mean is 70, and the standard deviation is 11. The distribution of X bar, here X bar is the distribution of sample means, and we can use the central limit theorem to help us fill that in. So the central limit theorem says if the original population is normal or the sample size is greater than 30, then the mean of the sampling distribution is equal to the mean of the original population, which in this case is 70, and the standard deviation of the sampling distribution is the standard deviation of the original population, which is 11, divided by the square root of n. So in this case, that's the square root of 16, which is 4, and rounded to 4 decimal places, that's 2.75. So these are the numbers for our sampling distribution. We have 70 here and 2.75 here. If a randomly selected individual tire is tested, find the probability that the number of miles in thousands before it will need replacement is between 68.8 and 72.8. Okay, so this is a question about a single individual tire, so we need to use the distribution for the original population. So we want the probability that X is between 68.8 and 72.8. A picture of that would be if this is 68.8 and this is 72.8, we want the area of the shaded region. So I'm going to jump over here to my online LibreText normal probability calculator, and I'm going to put in the mean and the standard deviation of the original population. So that's 70 and 11. And I click on between and put in the ends of the intervals in question. Click calculate, and to 4 decimals we get 0.1439. Now the next question is almost the same, but it's about the average of the 16 tires selected. So for this we need to use the X bar distribution. So here we want the probability 68.8 less than X bar less than 72.8. So the only difference is the standard deviation in this distribution. So I'm going to come over here to my calculator, clear out the old entries, and put in the new standard deviation, which is 2.75, and hit calculate. And to 4 decimals, we get 0.5144. Okay, find the first quartile for the average number of tire miles. So the first quartile is that number Z, such that 25% of the data lies to the left of Z. So the area of this tail is 0.25. So I'm going to come over here to my calculator and I'm going to clear everything out, switch the between to a less than, and put in the probability 0.25. And click calculate, and we get 68.1452. 68.1452. And finally, for part E, is the assumption that the distribution is normal necessary. And that's the answer to that is yes, because our sample size was 16, which is less than 30. And that's it.